I made a mistake. This should be 6.7% for the percent composition of hydrogen in order to have a total percent composition of 100%. All right, so if you could change that really quickly in that problem, that would be awesome. Okay, so what we're going to do to find your molecular formula, it's actually really easy. Your first step is to do the exact same thing as what we've been doing with empirical formula. So I'm going to first find my empirical formula, and then I'll be able to find my molecular formula. All right, so let's get started. Since I give you percents, you can assume that's just the exact same thing as grams. So I have 40 grams of carbon. Okay, and I'll just put carbon right here. I have 6.7 grams of hydrogen, so hydrogen's right there. 6.7 grams, awesome. Oops. And I have 53.3 grams of oxygen. All right, now my next step, I want to convert to moles. I'm just finding my empirical formula, so it's nothing new. Okay, so I'm going to put 1 mole up top because I'm converting first to moles. I'm going to put the atomic mass of carbon on bottom, so that's 12. Okay, so what you need to do in your calculator is do 40 divided by 12, and what you get is 3.33. 0.33 moles. Okay, awesome. That's for carbon. Let's do it for hydrogen now. I'm going to crisscross switch it. Guys, I know my atomic mass for hydrogen is 1 gram, but you still have to show this. I know it seems kind of pointless, but just in case. 6.7 moles, and I'm done with hydrogen. My last one's going to be oxygen, so I'm going to crisscross swoosh. I'm going to put 1 mole on bottom, and I'm going to put 1 mole on top and 16 grams on bottom. Okay, so then I'm going to take 53 divided by 16, and what I get is 3.3 as well. Okay, so just as with empirical formula as before, since that's actually what we're doing, we're going to divide by your smallest number, which in this problem happens to be 3.3. Okay, and I'm going to divide this by 3.3, and I'm going to divide this last one by 3.3. All right, so what you end up doing, if you do 3.33 divided by 3.3, you'll end up just getting 1. Okay, if you do the same thing but with 6.7 divided by 3.3, what you'll end up getting is 2.03, which is the same as saying 2. And this one's going to be 1. So, just as before, my empirical formula, guys, is just going to be CH2O. So it's really not that bad. That's my empirical formula. Now I want to find my molecular formula. All right? So all you have to do is the following. You've got to find the empirical mass of this. Okay, and what empirical mass means, it means the molecular mass of just this compound right here. And I say empirical because this is my empirical formula. All right, so carbon is 12. That has an atomic mass of 12. I've got 2 hydrogen, so it's plus 2. And I've got 16 for oxygen. So my total is just going to be 30 grams per mole. Okay. Now, in order to write my molecular formula, all I have to do is the following. I take whatever my given molecular mass is, which is 180, and I divide it by my empirical. So I'm given 180. I'm going to divide that by 30, and the number you get, guys, will always be a whole number. And in this case, it happens to be 6. Now, what that 6 represents is the number that you're going to have to multiply this entire thing by. Okay? So then what you end up getting for your molecular formula is just C6H12O6. And you're done. That's your molecular formula. This was your empirical formula. And as you can see, it's your lowest whole number ratio, right? You've got a 1, a 2, and a 1. Your molecular formula doesn't have to be the lowest whole number ratio. You've got a 6, a 12, a 6. You could technically simplify this, right? Which tells you it's not the lowest whole number ratio. But this is your molecular formula. That's what you would see in everyday life.